Okay, good morning, ladies and gentlemen. Welcome to the International Visiting Lecture today with Arunai Engineering College. Welcome to the Honorable Professor D. Karthika as an Assistant Professor, Artificial Intelligence. Yeah, and for the topic today is Algorithm Design Technique. And for today's session is being live streamed on the University STEKOM YouTube channel. And now I will read our agenda this afternoon. First, we will start class presentation delivered by Professor Karthika and continue with the main presentation. In the next session, we will start with Q&A session. In the next session, we have time for documentation and last time is closing. Okay, let's begin. We will start class presentation delivered by Professor Karthika. The time is yours. Thank you.
Thank you very much, madam. Ma'am, can you allow to share PPT?
Yes, you can start. Yeah, you can start. Yeah.
So I got message, post disable participant screen sharing. Madam,
Yes.
Still I can't share my screen.
Yes. Oh.
Ma'am, can you able to see my screen?
Yes, everything is perfect.
Okay. Thank you very much for my giving this opportunity. I am Mrs. D. Karthika, AP from the Department of Artificial Intelligence and Data Science, Arunai Engineering College, Tiruvannamalai, Tamil Nadu, India. So I would like to thanks to my management and my HOD. And today I'm going to share knowledge about algorithm design technique. So what is algorithm? So what is algorithm? How the problems can be able to solve using algorithmic instructions, and how we can measure the efficiency of an algorithm. What is asymptotic notation, and what are the analysis methods available to solve the particular problem, and what is algorithm visualization and types of problems, how it can be solved using algorithms, and finally we can conclude. Right. So first, introduction. So what is an algorithm? So algorithm is nothing. It is a step-by-step process. So let us assume one problem. We can able to solve that problem using set of instructions with this clear, which means unambiguous instruction. We can solve the problem. For example, if we are going to some n number, you can give the instruction to the computer. It will take the input and calculate it, and then it will print the output. So by using the instruction what we have passed to this computer. So it may be 3 types. There are many ways to give instruction to the computers. Probably it may be natural language, or it may be diagrammatical, that is a flowchart representation, or pseudocode representation. There are many techniques to solve the to write an algorithm, but we are focusing only few methods to write an algorithm. So first step, let us consider one natural language. In this we can give the instructions. So first let us assume sum of n numbers. What is the first step means we can take the input from n numbers. So suppose we are going to add first 5 numbers, we are going to add 1, 2, 3, 4, 5. So we can take the input. So give the clear instructions. Get the input from the users. That which means n value. Then we can calculate. We are adding those numbers and then give the results. So that we can give the instruction to the computer. That is this is called algorithm. Next, what are the properties available in algorithms? Non-ambiguity, range of inputs. So non-ambiguity means it is a clear instructions. So step, what are all we are going to do to solve the problem. That is the non-ambiguity, which means the instruction must be clear and understandable. Next, range of input. So range of input means here, for the example, we are assuming n equal to 5. So that is the range of instruction. If the input range is not specified in this algorithm, it will run for infinite static times, right? Next, multiplicity. So what is multiplicity? I already told there are many ways to represent an algorithm. So that is called multiplicity. And then finiteness. So finiteness is nothing. After performing what operation required, it should be terminated. So one certain period we are executing the algorithm. After that, it automatically terminates the algorithm. That is called finiteness. Next, speed. It is based on the efficiency. Next, this algorithm used in many applications. For example, we are using in sorting and searching, and what are the requirements means we are getting the input from the user and printing the result. So that is the requirement of this. So this is the small introduction about the algorithm and how the algorithm is used to solve the problem. First step, we have to design the algorithm, which means plan the algorithm, which means we can writing the instructions to the computer. Next, we can test with the sample inputs. For example, first in very first time we are using n equal to 5, and next time n equal to 10, and next time n equal to 15, so that we can get the clear idea about the samples. So how our algorithm is executed and how it will produce the output. Next, this is called implementation, and finally we are analyzing. So in what way we are performing the algorithms, we are calculation and then print the output. So these are all the algorithmic problem design techniques. And then how we can measure the efficiency of algorithm. So here the efficiency is nothing, how the algorithm is working, how it will take the time, how it will allot the space for this algorithm. That is called measuring of algorithm. So it has measured two types. First one is time complexity, and second one is space complexity. So time complexity is nothing but how much time it will take to execute the particular problem. It is fully based on the input size. If the input is getting more and more, then our algorithm also take a little more time, to execute the particular problem. So totally how much time it required to execute the certain problem, that is called time complexity. And space complexity, it is nothing but how much memory it required to store the particular problem. So actually we are writing the algorithm, right? So in computer memory, how much memory it will takes during the execution. So that is called time complexity. In basically the algorithm efficiency is measured using best case, worst case, average case performance. So best case is nothing. In a short period, we are executing the same problem. So let us take the same example. Another example. If we are going to find a certain key, let us assume one range of inputs like 1, 2, 3, 4, 5, 6. Here we are going to search 1 is present in the given list or not. If the if the key is present, then it is called present, and we are finding the key at the very first time itself, which means it will take minimum time to search a key. That is called best case. If we are finding the key at last, we are finding the key, then it is said to be worst case. In average case means n+2. That is in average time we are finding the same key. That is called average case. So minimum number of steps required to solve the problem is called best case. Maximum number of times it required to solve the same problem is called worst case, and average number of time it required to solve the problem, that is called average case. And the input size is based on the questions we are solving the problem. So actually we are solving the problem for many number of inputs, right? Next. So asymptotic notations. What is asymptotic notations? So it is a way that it describes how the efficiency is working. That is called asymptotic notations. So the way to describe the efficiency of algorithm, specifically how the running time or space usage grows as the input increases, approaching infinity. It focuses on the behavior of the algorithm, ignoring constant factors and lower order items. So there are 5 types to analyze the efficiency. First one is big O notation, and second one is big omega notation, and third one is big theta notation, and fourth little o and little omega. So we are focusing first 3 only. Yeah, that is the major. So big O, it is represented by big O, capital letter O. So that is called big O notation, which means it will used to represent worst case analysis. So if you are going to measure worst case, that is represented by big O notation. So big O notation represents the upper bound of the running time of an algorithm, so that it gives the worst case complexity of an algorithm. So it is most widely used notation for asymptotic analysis. It specifies the upper bound of a function. The maximum time required by an algorithm is called worst case time complexity. It runs highly possible outputs values, which is represented by big O, the capital letter big O. So we can simply, it is defined the condition that allows an algorithm to complete statement execution in the longest amount of time possible. It is said to be big O notation. And second one is big omega notation. So it actually it is used to represent lower bound, that which means best case in our problem. So omega notation represents the lower bound of the running time of an algorithm. Thus, it provides the best case complexity of an algorithm. So it executes time, serves as a lower bound of an algorithm's time complexity. It is simply we can define the condition that allows an algorithm to complete statement execution in a start amount of time, which means in a minimum amount of time we are executing the problem. That is said to be big omega notation. This is the symbol. This is the symbol we are representing big omega notation. And third one is big theta notation. Theta notation, which encloses the functions from the above and below. Since it represents the upper and lower bound of the running time of an algorithm, it is used for analyzing the average case complexity of the algorithm. Usually, theta, this average case, you can add the running time of the each possible input combinations and take the average in the average cases. So it is represented by this symbol. Represented by this symbol and little o. So which is little o means loose upper bound of the function, and roughly it is estimated of the maximum order of the growth, whereas big O may be actual order of the growth. So it is called little o notation. So it is represented by small letter O. Small letter O, this is function of an given function. So small O represents little o, and then little omega notation. Little omega, the actually the difference relationship between big omega and little omega is, which is similar that of looking at the bounder points, but little omega is rough estimation of the order of the growth, whereas big omega may represents exact order of the growth. We can use notations. This is for small letter w, for little omega, and this is the function of the given problem. So we can roughly estimate it using little omega, and actual growth is measured by big omega. And we are moving to the next slide. Analysis methods. There are two analysis we are focusing here. First one is empirical analysis, and second one is mathematical analysis. So what is empirical analysis? It means, which means analysis based on the observation.
Good morning, ma'am.
Yes, ma'am.
Yeah, your PowerPoint is not moved.
Yes, ma'am.
Still in the third page.
Ma'am.
Your PowerPoint is not moved. It's not moving for the slide.
Ma'am, I can't hear you. Come again.
Your PowerPoint is not moved.
Shall I continue, ma'am?
Your PowerPoint is not moved.
Yes. My screen is not visible. Actually sharing, ma'am.
Hello, ma'am. You can hear me?
Yes. Tell me,
Yes.
ma'am.
Yeah, still in the third page.
Still in third page.
Yeah.
Okay. 1 minute, ma'am.
Yes.
Now?
Yes, already.
I hope now it is clear, right?
Yes, ma'am.
Okay, shall I continue, ma'am?
Yeah, please go ahead.
Ma'am?
Please go ahead.
Okay, thank you very much. So there are two types of analysis methods. First one empirical analysis, and second one mathematical analysis. So empirical analysis, which means analysis is based on observation, experiments, or real world data. So this approach involves collecting the data through experiments or surveys or case studies. Then it can analyze it. So for example, if you are serving users of a new app, to evaluate its usability and satisfaction. So strength of this method is reflects real world behavior and outcomes. Next one is, second method is mathematical analysis. So mathematical analysis, which is based on mathematical equations, models, and logical reasonings. It uses the formulas, theorems, statistics, and calculation to drive the particular results. For example, using a profit equation to protect the future revenue of the business. So strength of this using this method is provide precise, generalizable, and logical consistent results, right? And going to next slide. Next, algorithm visualization. So what is algorithm visualization? Actually, which is a representation of visual representation. So it uses to visualize the algorithm in image format, like statistical images or animations, to help understand how algorithm works. So this approach improve the comprehension, especially for complex algorithm, by showing their step-by-step execution and interaction with the data. So this is called algorithm visualization. For example, flowchart, pseudocode. Here we are using many tools to show the visualization for the algorithms. So what is the flowchart? I already told there is a many way to represent an algorithm. This is a one format of representation, flowchart representation. Here the oval represents terminals and parallelogram represents inputs and outputs. So what input we are going to get from the user, and how what is the output we are going to print. That is called input and output. And this rectangular box represent calculation, that is processing. So we are calculating the let us assume n number, sum of n numbers. So we are calculating 1 plus 2 plus 3 plus 4 plus 5. This calculation process can be done in this rectangular boxes. This arrow represent the direction or flow of the program. This is the example for sum of n numbers. First, we are checking the given number is greater than 0. If it's greater than 0, then it will start the program. Then it will calculate some calculation 1 plus 2 plus 3 plus 4. Then it will show the output. This is the simple process of flowchart. And then so according to algorithm representation, it has many techniques to represent. So I already told many ways to represent a particular problem. Same like this, there are many techniques to represent the algorithms. So what are the techniques means? We are focusing here some few techniques. There is lot of techniques to solve the particular problem, but we are focusing only few techniques. First one is brute force, and second one is divide and conquer. Third one is dynamic programming, and fourth one is greedy technique. Fifth one is backtracking. Sixth one is branch and bound. In depth, brute force technique. So what is brute force technique? So it is a simplest technique of a design technique of the design algorithm. It is a straightforward approach to solve the problem, right? Usually directly based on the problem statement and definition of the concept involved. For examples, if we are going to calculate a power n, then we are using the brute force technique, and searching a key in a list, or computing n factorial, or we are going to match two strings, or traveling salesman problem, which means in what way we are calculating. So these are the few example in brute force technique. And then let us assume only one example, string matching. So it describes the concept of detecting the occurrence of a particular substring called a pattern. In another string is called text. There are different types. First we can write the algorithm for this string match. First, we are aligning the pattern at the beginning of the text and moving from left to right. Compare with each character pattern to the corresponding character in a text until all the characters are found to be matched, which is called successful search. Or if it is mismatch, the mismatch is detected, then this search is said to be unsuccessful search. So this is the small example for brute force in string matching technique. Then traveling salesman, TSP, represent traveling salesman problem. What is TSP? There are n cities, and traveling salesman has to visit each city exactly only once, and has to return back to the city from where he started. So we are calculating the distance, that is called TSP. And then knapsack problem. So knapsack problem, it is nothing but is a classical optimization problem in this design algorithm techniques. So the goal of this technique is maximize the total value of items selected to fit in a knapsack with a limited capacity. So this problem has different variation, with the most common being the zero fractional knapsack or 0/1 knapsack. And last one is assignment problem. So the fundamental concept of this assignment problem is search and manage the focused locating resources to task on a one-to-one basis. So objective of this type is minimize the cost or time or maximize the profit or benefit. By ensuring this, each resources is assigned to exactly only once to the person. So that is called assignment problem. So next technique is divide and conquer techniques. The name itself, you can clearly know that divide the problem statement into the sub problems, and we can merging after calculating, we are combining. So first step. So this problem is follows three major steps. First one is divide the problem into the smaller sub problems. For example, sub problem 1 and sub problem 2. Then these sub problems are solved independently. So this is the sub problem 1 and this is the sub problem 2. We are solving this sub problem independently. So sub problem 1 solved independently and sub problem 2 solved independently. If it necessary, we can subdivide into another sub problems. So, and finally, we can combine all the solution of the sub problems into a solution of the whole problem. So, in a sub problems are large. I already told, if the problem is large, then you can divide again and again. So, generally, sub problems are usually of same type as the original problem. Hence, recurrence algorithm are used in divide and conquer technique. So this is the example of we already know very much known about the sorting techniques like quick sort, merge sort. These are all the best example for divide and conquer technique. In merge sort, we can divide the given problem into two sub problems. Then further we can divide it into another four sub problems. Then we can arrange the numbers independently. Then we can merge all this. Finally we get the arranged list. Ascendingly arranged list, we get the final output. So that is the good example for divide and conquer technique. And then next technique is decrease and conquer. So decrease and conquer also similar to the divide and conquer technique. So in this problem, we can change an instant into one smaller instant of the problem. Solve the smaller instance and then convert the solution to the smaller instance into the solution for the larger instance. So probably problem can be solved using top-down manner or bottom-up manner. So any manner we can get the final results. So there are three variations in decrease and conquer method. First one is decrease by constant, and second one is decrease by constant factor, and third one is variable size decrease. So this is the one example for decrease and conquer technique. So first in this example, we know that first original problem is A, B, C, D, E, F. We can divide it into smaller substance, and then we can merge into this, and finally we can get the final solution. And next approach is dynamic programming. So dynamic programming it is also one of the familiar technique to solve the problem with overlapping sub problems. So in previous techniques, we are dividing the problem into many sub problems, then combining all those sub problems, and we get the final results. But in this case, we are using the sub problem answers, and then we get the solution. It may be memorization or it may be tabulation. Most of these problems usually tabulation methods. In this method, each sub problem is solved only once. Then the result of each sub problem is recorded in a table from which we can obtain a solution to the original problem. For example, for this dynamic problem is computing Fibonacci number for the n numbers and a binomial coefficient for the given list, or Floyd's algorithm, or optimally binary search tree. Let us assume one problem in optimal binary search tree. So, which means we are solving the sub problems and store the answer of this sub problems into the table. By using this table value, again we can proceed next. So finally, we are getting the solution to the given problem, original problem. So that is called dynamic problem. Next technique is greedy method. So in greedy, the decision of the solution is taken based on the information given. So this method is very straightforward method. In greedy technique, the solution is constructed through a sequence of steps, each expanding a particularly constructions set obtained so far until a complete solution to the problem is reached. So until the complete problem is solved, then only it will terminate it. Otherwise, it will repeat the each step again and again. At each step, the choice made should be, which means the choice made may be only feasible or locally optimal. So, what is feasible? It should satisfy the problem's constraints. And what is locally optimal? So among all these feasible solutions, the best choice is to be made. What is revocable? So once the particular choice is made, then it should not get changed on subsequent steps. So what are the applications we are using in greedy method? So first one, already discussed about knapsack problem. That problem also solved using this greedy method. And we are calculating the minimum spanning tree using this, job sequencing with the deadlines, finding shortest path between the given graph, and optimal storage of an tabs. So in this method, it always choose the local optimal solution. For example, here 36 minus 20 equal to, just we are calculating 16. So here the 20 is the local choice. So first we are choosing the local optimal solution, then we can use this, and then finally we get the solution. And next approach is iterative improvement algorithm. So iterative improvement algorithm in algorithm design technique, it is a start with an initial feasible solution and repeatedly defines it until an optimal solution is reached. So no further improvement is possible. This approach is particularly used for optimization problems where finding a good solution is more important than finding the absolute best, or when the problem space is too large to explore executely. Okay. So for example, for some problems, path to the solution is irrelevant. So just want a solution. For that, we are finding the optimal way to assign the data, and then we are choosing the data, and finally we give the result. And the next step is backtracking. So backtracking, what is backtracking? Backtracking is a kind of search technique. The basic idea is to construct a solution one component at a time and evaluate such partially constructed candidates as follows. So first one, if the partially constructed solution can be developed further by following the problem constraints, then remaining options are considered for the next component. If there is no legitimate option for the next component, so no alternatives or dead end occurs for any remaining component need to be considered. Backtracking is done to replace the last component of the partially constructed solution with the next option. Here we are using the term state space tree. So what is state space tree? It is a tree that represents all the feasible solution, all the possible states of the problems, from the root as the initial state to leaf as the terminal state. So it is called state space tree. In this example, the node is, in this example, we are starting this start node is the root node or initial node. From this, we are traveling A, then B. Here, we get the dead node and coming back to the node A. Then again, we are classifying the next path C. Again, we get the dead end. So we are again going back to the root, going back to the node A. Then there is no feasible solution for from the node A. Then coming back to the start node, which is root node. Then we are classifying our next node to D, D to E. Again, we are getting the dead node. Again, coming back to the node D. Then classify the node from D. We get F, G. So this is the successful node. So until reach the output, we are coming back to the previous component. That is called backtracking. So another good example for this one is Sudoku. So Sudoku games we are playing, right? So we are solving from row and column. The number should not be repeated. So that we are using the backtracking technique, just repeat the number and again placing another number, right? Same like this, backtracking is working. So this is called backtracking. And the next approach is branch and bound technique. So branch and bound algorithm is an improvement on backtracking algorithm. So this is the next level of backtracking algorithm. So this method is finding optimal solution. It is very similar to backtracking in that the state space tree is used to solve the problem. So I already told what is state space tree. So this state space tree is used to solve the backtracking problems. And then finally, we are so what is the difference between backtracking and branch and bound means it does not limit to any particular way to traverse the tree, and it is usually only for optimization problem. So the branch and bound algorithm computes a number at a node of node to determine whether the node is promising. The number is a bound and the value of the solution that could be obtained by expanding beyond the node. If the bound is no better than the value of the best solution found so far, the node is non-promising. Let us consider this example, root node. This is the example for branch and bound technique. So here the root is the initial state. Then subset 1, subset 2, subset 3, which means we are classifying the problems into the subset 1, subset 2, subset 3, then finally getting the solution 1 and solution 2. We are combining, we are scrutinizing this solution 1 and solution 2. We get the optimal solution. Okay, so next topic is algorithmic classes. 1 minute. So algorithmic complexity classes. So what in what is complexity classes? In complexity theory, a complexity classes is a set of problems with a related complexity. With the help of complexity theory, we can try to cover the some points, right? So first, class P problems. So what is class P problems? If the problem can be solved within the polynomial time, then it is said to be class P problems. So what is NP? Non-deterministic polynomial time, which means if the problem is not defined or not solved within the polynomial time, then the problem is said to be NP problems, which means non-deterministic polynomial problem. And then NP complete. So it is most difficult NP problems, which means we can't solve the problem within the polynomial time, but we can verify it within the polynomial time. For example, Sudoku games we can't solve within the polynomial time, right? But we can verify it. We can verify it within the polynomial time. That type of problem is said to be not NP complete, non-deterministic complete problems. And then NP hard. So which is also one type of NP problems, at least as odd as NP complete. So at least we can solve this problem. We can able to get the result. Then that type of problem is said to be NP hard problems. So what is the complexity of algorithm is, first it depends on two types. One is P class P problems, and another one is class NP problems. So class P problems means the problem can be solved within the polynomial time, then it is said to be class P problems. If the problem cannot be solved within the polynomial time, then it is said to be NP problems. So these are the major complexity classes of algorithms. Next, important problem types we are focusing on the algorithms. First, sorting problems. Second one is searching. Third one is numerical problems. Sorting means you know what is sorting. So we are arranging the given list, whether it may be in ascending order or it may be in descending order. That type of problem is said to be sorting problem. And another one is searching problem. So it may be many search available, linear search, binary search. So these are all the techniques we are having. So there are many techniques to search a key in a given list. So our aim is whether the key is present in the given list or not. That type of problem is said to be searching problem. And another one problem is numerical problem. Numerical problem means we know that mathematical or equation problem is said to be numerical problems. And fourth one is geometric problems. We are going to predict the weather based on some values from some data. We are predicting the weather upcoming, how the upcoming days will be. So it may be rainy or it may be cloudy. So it will be predicted using geometric problems. And then combinational problems. So it is nothing but a set of permutations problems is said to be combinational problems. And then graph problems. Graph, we know that what is graph? It contains set of nodes, set of vertices, and we can join through the graph using vertices. So that type of problem is to be graph problem. So we are finding the which one has the minimum spanning, which one has the maximum spanning. It can be calculated. That is that type of problem is said to be graph problems. And then last one is string processing problem. In previous example, I said there is a two string. One is called the pattern and another one is called the text. We are going to search the pattern is given pattern is present in the text or not. That type of string processing problems we are solving using this algorithms. And finally, we ended with the conclusion so that we can easily able to get the problem to be solved, right? Thank you.
Hello, ma'am.
Ma'am. Yes, ma'am.
We have some questions from participant already read in the Zoom chat.
Okay. One minute, madam. So how do we determine the most appropriate algorithm design technique? For example, you listed some techniques for real world problems with multiple constraints, right? So the problem can be broken into smaller sub problems. Then you can solve independently and combined. For example, merge sort, quick sort, binary search, matrix multiplications. So we can first you should compare with the two algorithms, then only we can finalize which one is most appropriate algorithm. No, sir. Optimizing time complexity and space complexity both are equal in real world, because if the space is not available means we cannot run. So time complexity and space complexity both are plays both are plays equal role while running the algorithm or getting the optimization. And how do algorithms design choices influences? um, Algorithm is a basic steps so that we can easily understand what is the problem given. So what way we are going to solve this problem, we can conclude in our mind. We can first get what is the problem is given. You can understand the given problem, so that we can easily communicate with the implications.
Hello, ma'am.
Ma'am, one
Yeah,
minute, ma'am.
oh, yeah.
One more questions. So human intuition plays a critical role in designing algorithms, especially during the initial stages of problem solving. So first you should understand the problem and modeling, and then choose the right algorithm design technique. and heuristics and approximation of this algorithm, and innovation and creativity. Finally, we can debug and optimize the given problem.
Oh, this is enough, ma'am?
Yes.
Yeah. Okay, thank you for answering. I guess no one else asking again. Before I close this event, for our participant, please open your camera. I will take a picture on the count of three. Okay, one, two, three. Again, another one, one, two, three. Thank you for your cooperation. Finally, we come to the end of visiting lecture today. We would like to thank you for Dr. Karthika for the wonderful information and sharing your knowledge. We hope this information will be beneficial for all participants. At least we hope to have more collaboration in the future. The visiting lecture for today and here. We hope to see you soon. Thank you and have a nice day. Yeah, thank you so
Thank
much.
you, ma'am. Thank you.